You're listening to After the Show, the Signals Everywhere podcast, where we teach you everything you need to know about software-defined radio. Today we'll be talking about why you should not throw away that hardware scanner once you start playing with software-defined radio. I'll be your host, Kerberos here with Signals Everywhere, and we have our guest host today, Loki. Loki, if you would.
Good afternoon, good morning, or whatever you are. My name's Loki, or as I'm known in the Signals Everywhere community as Merlin. My real name is Ray. You can find me on Twitter under twitter.com/cursory username.
Thank you for that great introduction, Loki. It's great to finally have you on the show as our co-host. And so with that said, let's jump right into the show. So in my case, when I first got into software-defined radio, I already had some hardware-based scanners. Now, a lot of people getting into the hobby today, they may have had a hardware scanner prior, or this might be your first time ever being introduced to radio communications. In today's episode, I really want to touch on the fact that hardware scanners are so amazingly important when it comes to playing around with the radio hobby. And while software-defined radios are amazingly useful with, the ability to pull things down in a waterfall and see a wide swath of bandwidth, they certainly do have some pitfalls. And so I wanted to touch on a lot of the things that you can do with a hardware scanner that you just simply can't do with a traditional software-defined radio.
Hardware scanners have an advantage, in my opinion anyway, have the advantage in that they don't require you to have a phone or a computer with you. So you're not required to pack a laptop as well as a phone, so you can see the waveforms and so on.
That is just, it's a really good point, especially when you start going out mobile. Traditionally, when I play around with SDR, I'm in the car or I'm, at home with a laptop, but I see more and more people using their cell phones when they go out scanning with the software-defined radio. And as much as these SDR apps for Android and iOS are, so amazingly helpful to have, they are, at least in my opinion, very, very clunky compared to a traditional hardware scanner. And there's just really no comparison when it comes to mobile, signal hunting. You're going to have a lot easier time finding something with a real hardware scanner.
Absolutely. And there's also things like some Uniden versions have close call, which is pretty much just a frequency counter, pretty much. It just picks up on localized contacts and automatically brings it up for you. That I have yet to see an SDR that is capable of doing that independently of a computer, for example. And then the next thing I have to say really is more based on the fact that they can scan through their banks or scan through a range a whole lot quicker than a traditional SDR can. So if you just to set up your small range, off it goes. That's it, and it keep going and going and going, depending on your squelch level and stuff like that.
Absolutely. And, that's the big thing with a lot of this is, the hardware scanner, when it comes to scanning, it has, physical hardware there. It's made to do this, and they can scan through things very rapidly. And while I have seen scanning improve with software-defined radio, in case with the SDR Uno series of RSP SDR Play software-defined radios, they've done a lot of things right with their scanning. However, at the end of the day, you're relying on a full-blown computer, and I haven't even seen this available for a phone. So you're really relying on a full-blown PC to be able to not only pull in that large swath of bandwidth, but rapidly tune across it. So as Loki had mentioned here, we have something really interesting with our hardware scanners is something called either close call or signal stalker. And essentially what this does, like you had mentioned, is it's essentially a frequency counter. So let's say you want to go out into an area and just look for new signals that maybe you want to come back later with an SDR to try and decode or play around with, but you don't know exactly what you're looking for. You're just trying to find new, interesting signals. This is where these hardware scanners really come into play very nicely. Close call and signal stalker, depending how they're set up on your scanner, you can set these up for all bands or individual bands, and essentially just looks for whatever signals are in your area that are the strongest. So when you're walking around in your area, say somebody keys up at 144 megahertz, as long as the signal is strong enough, it's immediately going to lock onto that signal, display that frequency, and then play the audio for you. In contrast, a few moments later, maybe you have, an officer or something driving by talking on 800 megahertz. Your scanner is going to immediately lock onto that, display that frequency, and play that audio for you as well. And it just becomes very, very intuitive way to go out and find signals Whereas with a software-defined radio, as amazing as they are, you're not going to be able to move around the band like that. You're very limited in the section or slice of bandwidth that you're looking at a given time. And with a hardware scanner, you don't have that limitation.
Yeah, absolutely. With SDRs, you're stuck usually to your little 10 megahertz bandwidth that you've pre-selected, whereas you can set a hardware scanner up to scan from 400 megahertz all the way up to 500 if you so wished, and off it would go. Whereas with an SDR, you're just scanning in whatever parts, 5 megahertz, 10 megahertz, so on and so on and so on, and you're manually flicking through versus having a piece of hardware that automatically does it for you.
Absolutely. And with that hardware, you also get added benefits such as, a signal meter in a lot of cases. I know a lot of you guys, if you watch the Signals Everywhere YouTube channel, you've probably noticed that I've been playing around a little bit with the Kerberos SDR, which is a 4 SDR coherence software defined radio. One of its main uses is for radio direction finding. And while having an array for direction finding can be very useful, once you start getting closer to a given signal that you're hunting, it tends to appear like it's coming from everywhere because the signal is so strong on top of those receiving antennas, you can't get a good bearing. So traditionally, you have to get out of the vehicle and walk around with some sort of handheld device, so that way you can find more accurately the location that signal is coming from. And with an SDR, you're going to have a really hard time doing that. But with a traditional scanner, assuming you have that set up for your given frequency and you have the proper antenna on it, you can look at that S meter and it'll give you a very accurate depiction of how strong that signal is coming into your receiver. So as you walk around one direction to the next, it's very easy to see whether or not you're moving in the correct direction and that signal is either getting stronger or weaker.
As you're hunting the signal, you would obviously have the scanner close to your body, and as you're sort of rotating around, rather than having the audio going out loud, you can simply just look down at the actual S meter and look. So on obviously where some people are looking around and they don't have an S meter, they would just listen to how strong the signal is. But with an S meter, it allows you to have the audio turned down, which gives you that slightly little bit more of an edge of discretion if you're hunting for, let's say, someone who's messing around with your repeater. For example, you're walking along, you've got the radio turned down, you're not going to have heads turning at you. They're just going to generally ignore you.
Absolutely. And, likewise, you're also going to run into a situation where, let's say you do want to listen to the audio, but the audio sounds, at least to your ear, very similar regardless of the direction you're moving. You might not notice a 1 dB change in RF signal coming into the radio, but that S meter more than likely will.
People might ask you, what is an S meter? Well, the S is simple. It's short for signal, and is used to provide the received signal level, which is an indication of the strength of an incoming signal, for example. S meters are calibrated pretty much in the same fashion with two different scales. The first 2/3 of the metering range is calibrated in what's called S units, which is a linear scale of 0 to, I believe, 9, and the units are read off as S1, S2, S3, so on all the way up to S9. And generally means that a signal is producing about 100 microvolts or so.
And so, now that you mentioned the S units, that's something a lot of people out there might be familiar with if they happen to be amateur radio operators, especially in the form of HF radio operation. You'll typically hear people, "Hey, you're 5'9", you're 4 over, S9," and they're basically letting you know, "Hey, your signal is extremely strong coming into my receiver," and so that's essentially how your S meter is going to function on that hardware radio. And anytime you're working with software-defined radio, your best indication of how strong a signal is looking at where it falls in dB on that waterfall. And unfortunately, it's just not very accurate. You could have a radio, sitting on top of you, and it's going to be blowing out your front end. You're going to have no idea if that's just a really strong signal 6 miles from you, or if it's somebody pushing 1 watt right behind you. And so having that S meter is just incredibly useful to see a little more accurately the strength of a given signal.
And looking through Google as well, there are a number of old scanners that you can buy on eBay for relatively cheaply, such as the old Pro 2042, which is the one I have. And looking through old text files, for example, there are loads of S meter modifications that you add into it that gives you an actual physical S meter to add. So you're not just reliant on the LCD.
Absolutely. You really don't have to break the bank at all when it comes to this sort of thing. You can typically find a scanner for about the same price as your SDR, and in many cases, it could have been a $200 or $300 scanner at the time of its production. Like Loki said, with some of the S meter modifications, I happen to have a Pro 2006, which is a pretty old desktop scanner, but extremely sensitive. It's great for things like listening to SATCOM and stuff because it is just so wideband. It'll actually go from somewhere in VHF all the way up to, I think, 1.2 gigahertz. So it's a very wideband receiver with no gaps. You can listen clear across the board. So I love this scanner. And like Loki said, with these S meter modifications, I have actually seen, and I can't remember where, I'll put a link in the show notes here, but there's a book that goes into all these modifications for the Pro 2006 scanner. One of which is where you can put in 9 LEDs into the front of that display, wire them up with, I think, an Arduino, and you can actually build an S meter directly into that radio.
Yeah, exactly. And that way, again, you're not reliant on having a computer switched on. So you may be in a low power situation, for example, and you want to be able to hear around what's going on around you. You don't necessarily want to be able to switch your computer on or waste your laptop battery or waste your phone battery on powering your SDR long term. So a lot of these scanners have modifications for them to be able to have external batteries, or in a lot of cases, you have actual handheld ones that accept a whole broad range of batteries from 9 volts right up to AA batteries.
Absolutely. And that's that portability that comes in so handy. I know that when I start playing around with software-defined radio or amateur radio satellites and things of that nature, it becomes difficult once you bring that hobby outdoors to do so in kind of a low-key environment. You end up with a lot of people who, they're staring at you, wondering what you're doing. And, if you're walking around your neighborhood looking for various signals, you might not be doing anything nefarious, but you don't really want to have that attention brought onto you to have to try and explain what you're doing. And so to be able to set the frequency band that you want to listen to, throw that scanner into your pocket and just put on a headset or some earbuds and be able to listen to all of these things going on around you without walking around with, say, a phone in one hand, an SDR and a directional antenna in the other. Yeah, and it really adds to what you can do with the radio hobby. You're not quite so limited in having to lug out all this other hardware.
Absolutely, especially in this so-called security conscious age, where people will see that kind of thing as suspicious, and you are likely to get attention. Yes, that you're not doing anything illegal generally, but it's always best just not to have that interaction anyway. That's just my opinion anyway.
Absolutely. And this could be anything from just a minor annoyance to somebody thinking that, and I've had it happen before where, I'm just, going around listening to various signals. I'm trying to find the location of, an interfering source of some type. And I've had people walk up to me thinking I'm listening to their phone or something because, hey, you've been walking around the block for an hour. What are you doing? Well, I'm not doing anything. It's me just seeing what's out here. It's me looking for an interfering signal. And you get these people who they see something that to them looks odd, and they're going to question what's going on. And it's best that if you can avoid that, you may as well take advantage of the portability and do so. And so with that being said, I wanted to turn our attention to the RTL-SDR.com blog, where Carl has announced that his first batch of Kerberos SDRs are nearing the end of stock, and they are taking discounted pre-orders for the next batch coming out. If you're not familiar with the Kerberos SDR, it is a 4 RTL SDR coherent software-defined radio used for direction finding and passive radar. And I'm sure as the software improves and is developed over time, we'll be able to do a lot more with these software-defined radios in the future. So I'll leave a link in the show notes here if you're interested in picking one of these up. At the time of this recording, there are only 9 of these units left in the first batch. They retail for $150 US on Indiegogo, and the discounted price is at only $130. So you are getting a 13% discount if you pre-order out of batch 2. And there are 7 out of 1,000 of those currently claimed. So there's plenty of room for you to pick one of these up at the discounted price if you're interested. And we're going to head over to Loki here, who has also picked out an interesting article that he'd like to kind of share with you guys before we get back onto our topic of hardware scanners.
So looking back on the blog, there was one that was very interesting. It was on the April 5th of this year. The NUT2NT open source GNSS RF to bits receiver. So looking through, in May 2018, they posted about Amungo Navigation's NUT4NT project, which is a 4-channel global navigation satellite system based on a certain chipset, the NT1065. But the right antenna is capable of receiving any navigation information from all different constellations such as GPS, GLONASS, Galileo, Beidou, IRNSS, and QZSS. And it's got multiple access up to multiple satellites. And they're currently crowdfunding for their new board, which is currently down at $250 and the normal price being $320. Compared to the legacy version, they say it also has a FPGA, a TCXO, a temperature-controlled crystal, local oscillator, and a bias T and other improvements. They've sort of brought it on, and they've also used the higher-end 4 channels can be used as a coherent receiver as well, which can be used to locate sources of GPS jamming. As in the car, there's a video at the bottom of it. XNZR is searching for Moscow GPS spoofing anomaly, so you can see around the Kremlin where they've highlighted hotspots for GPS spoofing.
So that's a really cool article. I wasn't actually aware of that particular project. I go through the RTL blog all the time. Somehow I must have missed that one. It's really interesting to see that they're using that as a 4 coherence receiver, tracking GPS interference and jamming. That's a pretty cool way of doing that. I wouldn't have thought to set something up that way. And I'm sure that maybe in relation to a lot of the Russian jamming that's been talked about here recently. I think they said it was supposedly Vladimir Putin's been traveling with a mobile GPS jammer for protection against ballistic missiles and things of that nature. So I would imagine that this would be one way to try and counter that by tracking exactly where the signal of that jammer is coming from, because anyone who's familiar with GPS and other navigational satellite systems, you likely know that those signals are incredibly weak. And so if somebody's jamming or spoofing those on a terrestrial surface, it's going to be a lot easier to find that signal because it's going to be amazingly strong in comparison. It sounds like this is the perfect project to try and hunt down something of that nature.
Absolutely. And it also puts a little bit of power back into the normal man's hands, which is always a good thing in my opinion. Not to get too political, but I think it's always nice to know what people are up to on our behalf or on other people's behalf,
Absolutely. And, it's just another one of those projects where you can, gather your own information without having to rely on some third party. So it's a really cool project to see out there. And of course, we'll have links in the show notes to that if you're interested in that project as well. Going back to our hardware scanner discussion for the day, I also wanted to mention, a big difference between analog scanners and digital scanners. And I think this is a lot of what turns people off to a hardware scanner in the first place. A digital scanner, which is what we see most of the time on the market just because they are the newer standard, is you're going to be paying $500, $600, $700 or more for that digital scanner because it supports DMR, P25, 1 and 2, and a number of other digital modes. But you don't necessarily have to spend that kind of money. In the terms of digital modes, you can use something like DSD Fastlane or just the traditional DSD Plus application to decode all of those with software-defined radio. But this, of course, comes back to our topic before on portability. You're not going to have that ease of use where you can just walk around your local area and listen to these systems. If you've ever seen my YouTube video, and I'll leave a link in the show notes, to where I put all this software-defined radio equipment in my car, I'm actually using a full-blown Windows computer to decode the P25 Phase 1 system in my area. And I do this because it's cheaper, but it's not very portable or practical. So there is that convenience in having a hardware scanner. Now, that being said, just because they make scanners that are digital doesn't mean you have to buy a digital scanner if you want to have things like close call and fast scanning. You can very easily go on eBay or go on Amazon and find these old scanners. I myself use a Pro 97 scanner, which is, I think it was an old Radio Shack brand, and this thing will do all kinds of different modes for me. I myself use a Pro 97 scanner. No, I don't. I use a 96. I myself use a Pro 90. No, it is. God damn it. What is it? I myself use a Pro 96 scanner, which is amazingly cheap nowadays. It'll do analog, it'll do AM, and it'll scan all across the band for me with that close call functionality. And you can buy these without breaking the bank. So you do get really the best of both worlds when it comes to portability and using a hardware scanner. And if you really need digital, you can either go for that digital scanner or fall back on the amazing tool that we have, which is software-defined radio. And so one of the final topics I want to touch on here is the state of repairability between the small components in a software-defined radio and a scanner itself. And so I'm going to go ahead and let Loki take it away from here, and then we'll move on to our final closing points.
With the hardware scanner, it's a simple case of unscrewing the case, and in you go, and you're usually greeted with some nice through-hole technology. I mean, there'll be some surface mount and stuff there, but mostly, if you've blown a capacitor, that's awesome, man. I'm just going to go in, unsolder one. I'm going to pick one up for 20 cents or 20 euros, or 20 euros, 20p, or whatever, 20 euro cents, and it goes back on you go. Versus the brand new Lime SDR minis, which people have to send in to dedicated repair shops, and they'll be there for months, for example, for people who do work on surface mount. I generally find it's a little bit easier. And there's also the fact that you can have modifications, like my Pro 2042, for example. It's got just the one, my one doesn't. There is an internal antenna, which I've taken out because it was snapped anyway. And I've just soldered on a BNC pigtail, which I've also done a chassis connection to. I'll put pictures in the show notes. There's a BNC pigtail on it. So now it's got two antennas as opposed to just a broken internal antenna and an external one. I wouldn't be able to do that with an SDR. I wouldn't be able to give myself two antennas to do things,
If my SDR breaks, you pull it open and you have all these amazingly tiny parts, and the tip of your screwdriver would probably pluck 6 of them off of there. Whereas if you have a problem with a hardware-based radio scanner, the components are much easier to work with. They're easier to source and replace, and you run into a situation where you can fix something that otherwise you'd probably end up throwing in the trash. And with that being said, I hope you guys enjoyed today's podcast. If you'd like to get access to any of the show notes and other things that we've spoke about on today's episode, please go over to signalseverywhere.com/podcast, and you'll be able to find all of our episodes, including this one, and the show notes for everything that we talked about over the course of the episode.